Good afternoon, guys. My name is Ramiro Mata, and today I'm going to do a lesson on quadratic equations. But my quadratic equations that I'm going to be working on, I will be putting them in vertex form. And in order for me to do that, I'm going to go ahead and use some tiles as my model to represent my equations, quadratic equations in vertex form. So I'm going to stick with blue, meaning that my numbers that I'm going to work with are going to be strictly positive. So my function that I want to write in vertex form is the following. X squared plus 8x plus 2. And so what I'm going to do is to represent this particular graph or function, I'm going to use a big square, and that's going to be x squared. And then I'm going to have 8 x's. And notice again that these are blue, so they're all positive terms. And so I have 6 at the moment, that will be 8. And then I have 2 little ones, which is my 2 unit ones, and they're going to be blue once again. So what I'm trying to do here, yes?
One of them is red.
One of them is red, thank you. I was trying to see if you pay attention. Okay, so now this is 8 blue, okay, and 2 little ones. So x squared, 8x, and 2 unit ones. And so the first thing I'm going to do to represent this function, or to show you how we're going to put this in vertex form, is the following. I'm going to try and make this into a perfect square, which is a topic that was covered by one of my colleagues. And so I'm going to have an x squared term here. And then what I'm going to do is, first thing I'm going to do is I'm going to look at the 8 ones, 8 units. And if we look at this in terms of construction, think about building a perfect home. Okay? If I have a perfect home, what I want to do is I want to make sure that I split the boards in half. So half of the boards will be on the right side and half of the boards will be on top. So by doing this, this would allow me to now construct my perfect home in the real life situation. So all I need to do is, of course, I have to add some little ones. At the very beginning I had 2, however I know, is that going to be sufficient? Most likely not. So what I'm going to have to do is I'm going to have to add, and this is where completing this square comes into play. So first, I split my x terms in half. So half of 8 happens to be 4. And so now, if you look at the model here, you should be able to recognize that in order for me to fill this in, I'm going to need quite a few little ones. And so if I go back to my little ones, you're going to realize that I have a 4 by 4, a length times a width. And so that will give me, I'm just going to ignore my little ones over here. Notice that I'm adding, this is something that was not there. I'm going to be adding a total of 16, because 4 times 4 will give you 16. And so by doing that, these little ones that I'm adding is something that I have to take away. So I now have 11, 12, a total of 16. That's the 12th one, and then I need 4 more. So if I add 16, notice that these 16s that I'm adding, 16 little ones that I'm adding, weren't there to begin with. So that's something that I had to do in order for me to complete the square. And that's the reason why we say we always add. Because if you don't add something, then you'll never make that to look like a perfect square. So now, since I'm putting something that wasn't in there, I have to compensate by taking it away. And so that's how I'm going to introduce the red tiles. So by me introducing the red tiles, notice now that if you look at the 16 blue, I can compensate that by putting 16 red. Now by putting 16 red, that means that the blue and the red will cancel themselves out. So what I'm going to do is I'm going to put this to a side here and then show you that this is a perfect square. So if I want to find the dimensions of this particular square right here, then it's as easy as going back to my model, which is, again, I started out with a big x squared, 8 little x's, 4 on the side, 4 on the top. I split that in half, and then I had to square it in order for me to make it a perfect square. So now I know that the dimensions of this particular home that I will call are x plus 4 times x plus 4. And so that would make it a perfect square. And so now I have to go back and look at my red ones and my blue ones. Notice that I have 15 red and I'm adding 2 blue. And if I go negative 15 plus 2, that will give you negative 13. And this is called completing the square to put this in vertex form. Okay? So using a model of what I would call a home, building homes, then I'm able to use the mathematics to complete the square. Okay? So my perfect home being again the perfect square. Now in real life, if you look at the sectors, every fourth home happens to be the same. And so in general, what they do is they have people, construction workers come in and build one home at a time. So by the time they build 4 homes, they have their homes inside here, they got the patterns. So when they go and build the same house again, it's built a lot quicker, so it's money efficiency. So the construction companies will be happy to know that they spent $100,000 building a home when they're gonna sell it for $500,000 and they make a nice profit. So, in summary, how do I use construction so that I can make a perfect home? First, this is your home. When you want to build one perfect home, you have to see how many boards you need. If I have 8 boards, we cut it in half. We go 4 to the right, 4 on top, and then that will show you that I need to have 16 little ones in order for me to build the home. And so now that's going to be a perfect square. So by having this, then I have to compensate by, if I added 15 or 16 little ones, I have to remove by putting red ones. And then these were the 2 that I started off with. So now I can add these 2, negative 15 plus 2, that will give you negative 13. And that will give you a perfect square. And then adding the little ones will give you that negative 13 in there. So what if I wanted to build 2 homes, 3 homes? Well, the idea is the same because it's still going to be a perfect house. Once you build a perfect house, suppose I'm going to add 16. And if I want to build 3 houses, then I go 16 times 3. So really you haven't added 16. You've added 3 times 16, which is 48. So if I add 48, what do? I take away 48. So that's my visual to you guys. What I'm going to do is I'm going to have us do one ourselves so we can use that GRR, or known as gradual release responsibility. So in doing so, what I'm going to give you now is only that. So we're going to build a home together to see if we get the same thing. So if I have 4 boards here and I'm trying to build a perfect home, and let's say I give you only one little one. So right now, what have I given you? X squared plus
4x
plus 1. Okay. So if I'm going to build a perfect home, how many boards do I need on this side?
2.
And how many boards do I need on this side?
2.
Notice that I'm going to just relax with that one on the side. So how many little ones am I going to need to build this perfect home?
4.
So I'm going to add 4, right? So if I add 4, now I have a perfect home. But notice that if we add 4 boards, how do I compensate that?
Take 4 away.
And that's when the red ones come into play. So if they come into play, now can you see that we have a perfect home?
Yeah.
Okay. And so this will be, what are the dimensions of my perfect home?
X plus 2.
X plus 2 times
X plus 2.
2. And that's x plus 2 quantity squared. And then if I look at the little ones, what would I have there? Minus 3, because these 2 will cancel. And so my vertex form for this particular problem, which we said at the very beginning, it was x squared plus 4x plus 1 happens to be, according to their dimensions here, happens to be x plus 2 quantity squared and then minus 3. Okay, so there you go. I do, we do. Now, I like you to take this one for yourself, where I gave you 4 boards, actually 2 boards, and 3 little blue ones, and I want you to see if you can come up with your own model. Or maybe one of you come up here and represent it really quick. Juan, would you like to come up here and show me what time real quick?
Okay. So have x squared there, two of these, so that means we have, so for this problem we have x squared plus 2x plus 3.
Yes.
Let's see. And I'm going to build a perfect home, so I'm going to put one here. I'm going to put one here. And it looks like I'm going to need, one, which wasn't
Excellent.
there.
Yes.
And so I got to subtract one.
Beautiful.
So those are the three I started with. I'm subtracting one. So that means I'm left with 2.
There you go.
So my perfect square is going to be x there and one more. That's x plus 1. And this is also x here and 1 there. So that's quantity squared plus 2.
Excellent. Very nice. And so, as you can see, we have just met the requirement of gradual release program where I presented a problem, we worked together on one, and then you were able to do one yourself. So in conclusion, I'd like to thank you guys for looking at my video here. We have done gradual release program, and I have shown you through models and using an interpretation of how construction works in the real life with mathematics. Building one home at a time. So by the time you build a 20th home, you have how many boards, how many nails, how many walls, per se, if you may, that you're gonna have. So it's a very simple construction that I guarantee you that your company will love for you to hire you because you're gonna make a lot of money for them. So in conclusion, I am done. Thank you.